What's up, guys? Alright, in this video we are going to be solving rational equations. So all that means we're going to be solving with fractions. That's really about what we're going to be doing today. Alright, so the biggest thing to remember, we cannot divide by zero. It's not possible. So if we get any solutions and we check our solutions and we're dividing by zero, it's not possible. So for instance, like here, I know that 2x minus 3 cannot be equal to 0. It's not possible. So what that means is we cannot have x equal to 3 over 2. So if we get 3 over 2 as a solution, it's not really a solution. It's being tricky. All right, so let's check it out. So here, I notice I have a fraction equals a fraction. So something you learned in middle school was to cross multiply. We can do that here as long as you have a fraction equals a fraction. Because essentially what I'm doing is I'm multiplying by 2x minus 3 on both sides. So if I multiply by 2x minus 3 on both sides, then that makes that be 1. Likewise, if I multiply by 5 on both sides as well, the 5's here divide, and I'm left with times 5 right there. So what that creates is 20 equals 2x squared minus 3x. Well, hey-oh, we have a quadratic, so we better make it equal 0, so we can factor. So 2x squared minus 3x minus 20. I wish I could divide it all by 2, but I can't. So let's try to factor it as is right now. So I have 0 equals 2x and x. So let's see, 4 and 5, maybe. 2 and 10, probably not. Definitely not. So you guys can see I have some trouble with these two. So like, take your time on these. Make sure you check your work. But I'm going to try 5 would be 10, and 4, no. 2 and 10, no. I don't think this factors. All right, well, bang. So if it doesn't factor, the other thing we have is quadratic formula. So I have x equals negative b, which is 3 plus or minus the square root of b squared, so 9 minus 4 times a times c. Since c is negative, it'll be plus. So 4 times 2 is 8 times 20 is 160. All over 2 times a, which would be 4. So, that means it did factor. So I think 169 is 13. Dang, I don't know what I didn't see. All right, anyways, so x equals 3 plus or minus 13 over 4. So we should have x equals 16 over 4, and 3 minus 13 would be negative 10 over 4, which is 4, and negative 5 over 2. 2x, so that means it would be plus 5 minus 4. Minus 8. Yeah, minus 8 plus 5. Whoops. All right, anyways. So those would be our two solutions. So you can see it'll work out with quadratic formula as well. Yeah, I did it the long way. I'm sorry. So summer. All right. So I have x equals 4 and negative 5 over 2. Since neither of those are 3 over 2, they are both good solutions. So I can have two solutions to that equation. And another way you could check this too is if you plug these back into your equation, you would have 4 over 5, like if we use x equals 4, 4 over 5, and 4 over 2 times 4 minus 3, which would be 8 minus 3 is 5, so 4 over 5, so 4 over 5 equals 4 over 5. You can check your answers by plugging in your x values. That's all I'm trying to get at. All right, with b, this one's a little bit different. Yeah, they're both fractions, but what I see is this will factor as x plus 7 and x minus 7 right there. So what that tells me is for my solutions, make sure we're not on that one, x cannot be equal to 7 or negative 7. The reason being, negative 7 would make that 0, positive 7 would make this 0, so 0 times that would be 0. So neither of those numbers should work as solutions. And I like to get a common denominator with these, and here's why. Is if I get a common denominator, all right, so now this is x minus 7 over x times x plus 7, and x plus 7 times x minus 7. since the denominators are the same, right? I have 2x, 2 times x minus 7 over x plus 7, x minus 7 equals x over x plus 7, x minus 7. Right? Since the denominators are the same, if the denominators are the same, the numerators have to be equal to each other in order for this to be true. Right? So something over x plus 7 times x minus 7 equals something over x plus 7 times x minus 7. These two things have to be equal in order for this whole equation to be equal. So what that allows me to do is I can say then that 2x minus 14, if I distribute the 2, has to equal x for this to be true, which makes it a lot easier to solve. I don't have to use a quadratic formula, anything like that. So now I can say minus the x plus the 14, so that just gives me x equals 14. There's my solution. It's not 7 or negative 7, so I am good to go. I know that's the answer. Cool. So let's try the same thing with part C here. Because I know this will factor as x plus 3 times x minus 3. So I need to have the common factor, so I need to multiply this one by x plus 3, numerator and denominator, and this one by x minus 3, numerator and denominator. So what that says, 2 times x plus 3, and then minus 4 times x minus 3 is equal to that numerator, which is 8. Again, since all of the denominators, I'll do it in a different color, since all the denominators are x plus 3, x minus 3, I can take the entire numerators and set them equal to each other. It has to be true for that to be working. So then 2 times x plus 3 is 2x plus 6 minus 4x plus 12 equals 8. Combine like terms. Negative 2x plus 18 equals 8. Subtract the 18. So negative 2x equals negative 10. Divide by negative 2x equals 5. There is our one and only solution. I know it works because if I plug it in, 5 minus 3 is 2. 5 plus 3 is 8. The only things that would not have worked here would have been positive and negative 3. All right, moving on. So here a little bit different, but still the same sort of idea. I would get all of the denominators the same, because if I factor it, is 3 times x minus 4, that means I need to multiply this one by 3, and I need to multiply this one by x minus 4 over x minus 4. All right, so now they're all 3 times x minus 4, so I can say 7 minus 1 times 3 equals 2 times x minus 4. If you want to take a second and say what x cannot be, I only have an x minus 4 in my denominators anywhere, so x cannot be the solution to that, which would be 4. So then I continue solving. 7 minus 3 equals 2x minus 8. 7 minus 3 is 4, equals 2x minus 8. Add the 8 over, so 12 equals 2x. Divide by the 2, so x equals 6. It's not 4, so I know that's a good solution. Alrighty. So here, even more, a little bit different, but here's what I do. Notice, these have the same denominator already. So just like we can add and subtract numbers like 2x or 3 or whatever, I can subtract this entire fraction. So if I subtract 5 over x minus 1 from both sides, that makes that 0 on that side. So what I create then is 4 over x minus 1 minus 5 over x minus 1 equals 2. Now the cool thing about that is that these both have the same denominator already. So since they have the same denominator, like we did in a few videos back, 4 minus 5 is negative 1 over, keep the same denominator. And then it becomes much easier, because what I would do next is multiply by, multiply by x minus 1 on both sides, right? So that divides, and I'm left with negative 1 equals 2x minus 2. Going back to my original, I know x cannot be 1. I don't know why I just thought about it now, but it can't. So if I add 2, getting ahead of myself, and it's not even 3, plus 2, then this would be 1 equals 2x, so x would equal 1 over 2 when I divide both sides by 2, which is not 1, so that's a good solution. All right, looking at part F, last one. Same sort of idea. I notice that these have the same denominator. So what I'm going to do, save myself some time, and I'm going to subtract this whole fraction so that it makes it 0 on that side, and I have x plus 6 over 5 minus 2x minus 4 over 5 equals negative 3. Make sure you keep that sign with that 3 as you go down. All right, so now here's the thing to be careful with. Again, like we were doing when we were adding and subtracting fractions, that's minus. So this needs to be minus 2x, minus a negative 4, so that'll be plus 4. So when I do this, x minus 2x is negative x, 6 plus 4 is plus 10, over 5 equals negative 3. So now I can multiply both sides by 5 to get rid of the denominator there. So I have negative x plus 10 equals negative 15. I would subtract the 10, so negative x equals negative 25. Divide by negative 1 or multiply by negative 1 makes no difference. So x equals positive 25. Looking at our beginning, there's no x value it couldn't have been because I don't have any x's in the denominators. But make sure you guys check for that because there could be no solution. Like for instance, if I have 3 over x minus 4 equals, I don't know, 1. I know there's going to be a solution. But blah, 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 random work, somehow magically, poof, we get an answer of x equals 4, which isn't right for this one. That's not correct for this one. But if I did, that's all I'm saying. If I got x equals 4, check it right there. If I put in a 4 for x, that would have been 4 minus 4, which is 0. I cannot divide by 0. So this would not have been a solution, and I would have said there are no solutions. Right? Again, that's not the solution for this equation, but if it was, I'm saying hypothetically, if it was, we cannot use it because 4 minus 4 is 0. You cannot divide by 0 ever, even as a solution. So there would be no solutions for that problem. So be careful as you guys are going through this stuff. All right, that's really all I got for you guys. I will talk to you soon. Again, email me. Let me know if you guys have any questions. I'm here for you. I look forward to your questions, helping you guys out. All right, I'll talk to you soon. Bye.